Hello everybody, welcome back to Math 1350. We're going to look at Chapter 3, Section 4, the homework assignments, the solutions of them. Alright, let's look at the first one. Find, if possible, the whole number there that makes the equation true. So we have 45 equals 27 plus 2 times some number. So we have to solve, basically, this is x. So we have to solve for x. The process is, it's reverse. In order of operations, it says you have to do multiplication first and division, and then so here, when we solve for something, you have to work backwards. The first thing you have to get rid of, anything pluses or minus to the x. So we have to get rid of 27. Again, it's a process of opposites. The opposite of 27 is negative 27. So we subtract 27 from both sides. They cancel. But since 5 minus 7 doesn't exist, so let's borrow a 1. 15 minus 7 is 8. 3 minus 2 is 1. Equals 2x. It's 2 times x. So to try and get x by itself, we have to get rid of the 2. Since that's multiplication, the opposite is division. We have to divide both sides by 2. So x, 18 divided by 2 is 9. Is 9. Alright, the next one. We have 43 base 5 times 3 base 5. So what we have to do first is, let's convert these into our base 10s. The steps are going to be these. Convert to base 10. Do the operation. Whatever the question is asking here, it's multiplication. And then when you finish, return to original base. So here we start with base 5. So what we have to do first is convert to base 10. So the way we do this, remember, this is not 43. It's 43 in base 5. So we have to first look at 5 to the 0 power is 1. 5 to the 1 is 5. 5 to the 2 is 25. And 5 to the 3 is 125. But that's much bigger than we need. So what we really need is just these two. We need to, so we have 4 here and 3 here. This is the base 5. These are the equivalent base 10. We need 3 of these. So 3 times 1 is 3. 4 times 5, we need 5 of those. 4 times 5 is 20. Add those together, we get 23. So 4, 3 at base 5 is 23 in our base 10 numbers. And now we have to figure out what this one is. Since only one digit, 3 times 1 is 3. So this one times is just 3. Multiply these two together. So that's what we first converted these numbers from base 5 to base 10. Now we're going to do the operation. 23 times 3 is 69. Remember, these are still base 10. Now we have to convert 69 into base 5. The way we do that is 5 to the 0, 5 to the 1, 5 to the 2, and we only need 69. So 5 to the 3 is 125. Again, that's too big. So we're going to do it. So How many times does 25 fit into 69? 2 times. 2 times 25 is 50. So we start off with 69, we subtract 50. So that does it for that column. Now, 5s. How many times does 5 go into 19? 3. 3 times 5 is 15. So subtract 15. You get 4. So how many 1s fit in 4? 4. So it's 4 times 1 is 4. If we add these up together, 50 plus 15 is 65. So this is our number we're looking at. So 69 is 2, 3, 4 in base 5. So our answer is 2, 3, 4. Now, let's look at the next one. Women's clothing store has designs for 7 shirts, 3 pants, and 4 jackets. How many shirt, pant, jacket outfits are possible? So we have 7 times 3 is 21. So with shirts and pants alone, we can make 21 outfits. So now we also have to throw in the 4 jackets. So we multiply those, we get 84. So there are 84 possible outfits you could create out of that combination of clothes. Number 4. Decide whether or not a set is closed under multiplication. Okay, what closed means under multiplication is if I choose any 2 numbers from the set and multiply it, since we're looking at multiplication, and multiply them, then the answer is a number that is in the set. So for the example here, this one we're dealing with just the natural numbers, the counting numbers. In other words, if we take any 2 of these numbers, 1 times 2, 1 times 2 is 2. Is 2 in the set? Yes. How about we took 4 and 4? 4 times 4 is 16. If we go on further, yes, 16's in there. So yes, this set is closed. How about all the whole numbers? The difference between whole numbers and natural numbers. These are natural numbers. Or are counting numbers. Whole numbers are natural numbers, but they start off with 0. So it starts with 0, 1, 2, 3, 4, and so on forth, so to infinity. Yeah, so 0 times 4 is 0. Is 0 in the set? Yes, so it's closed. Ooh, now we have this one. Again, W is whole numbers. That's the W. So it says all the whole numbers. That's a set from 0, 1, 2, 3, 4, 5, and so on and so forth, minus the number 2. In other words, this one says get rid of that number. So our set is 0, 1, 3, 4, 5, 6, and so on and so forth. Is that closed? Yeah, 0 times 1 is 0. 1 times 3 is 3. 1. So yeah, if we take away 2, the only way a number can equal 2 is if it multiplies by 1. And since there's no 2, it can't multiply to be equal to, so all these numbers when they multiply, it's closed because they equal a number inside the set. All right, the next set of questions. State the property illustrated. 4 times 0. Okay, so this is 0 multiplication property. Because it's 0. Anything times 0 is 0. State the property that's illustrated. 6 times 13 equals 13 times 6. Only thing difference here is I moved them around. I commuted them in its multiplication. It's not distributive, not associative. Okay, remember, distributive looks like this. So you have parentheses and you have multiplication and addition. Associative is when you have more than 2 elements and you have parentheses around just 2 of them. It tells you which one do you associate first. In this case, it's all multiplied. The identity property of multiplication, what that says is any number times 1 is itself. And that's not what that says. So it's commutative property of multiplication. X times y is the same thing as y times x. That's exactly what's happening. We just rearrange them. So it's D. Number 9. State the property. Remember, commutative property is when you move them around. Nothing's moved around, so that's not right. Associative property, when you have more than 3? No. Distributive property of multiplication over addition. Well, there's no addition, so that can't be right. So it has to be D. But more so, the reason it has to be D is because the identity property, 1 times anything is itself. 1 times 9 times 10 equals 9 times 10. So it's the identity property of multiplication. Rewrite this equation. A times B plus C minus D P plus Q without parentheses. So what we have to do here, that's what the distributive property is. The distributive property, when we do, it gets rid of parentheses. That's what the distributive property does. It gets rid of parentheses. So when you're asked to get rid of parentheses, we have to use the distributive property. Since this is A times B plus C, whatever's in front, A times B. Well, let's look at first. Always treat the signs and numbers differently. This is positive, so positive times positive is positive. A times B is AB. Positive times positive is positive. A times C is AC. Okay, that does it for that one. Negative times positive is negative. D times P is DP, Dr. Pepper, which is what I'm drinking. Negative times positive is negative. D times Q is Dairy Queen, which is where I had dinner last night. So there's my answer. So I'm looking for AB plus AC. AB plus, so that's not it. AB plus AC, AB plus AC. So far so good. Minus, this one can't be, has a plus. DP minus DQ. So it has to be B. Because it has a plus, minus, minus. Plus, minus, minus. Use the distributive property to factor the following. Use the distributive property to factor the following. Okay, now this is what's interesting. The distributive property, as we said earlier, goes from here to this. It gets rid of the parentheses. So A times X, A times Y. But Because it's an equal sign, we can go both directions. What do both of these terms have in common? They both have an a. If I remove the a from both of these, what do I have left? X plus y. So that's how distributive works. It works two ways. From this way to that way is distributive. From this way to that way is factoring. It's the same equation. That's why it's a super powerful equation. So let's look what we have here. We have y plus 1 times x plus y plus 1. We have two terms. Because remember, a term is anything separated by a plus or minus. And there's the plus. So we have two terms. What do they both have in common? They both have a y plus 1. So if I remove these y pluses 1s, what do I have left? And this goes inside the second parenthesis. X plus, well, there has to be a number. If there's no number, it's automatically a 1. And there's the factored form. So it's y plus 1, x plus 1, it's c. So be very careful. Even though if there's no number in front of a parenthesis or in front of a variable, then there's a 1. For example, 4x plus x equals 5x. Why is it 5x? Because there's a 1 right there. So 4 plus 1 is 5. The same thing works when we're doing factoring and stuff like that. All right, so that's chapter 3, section 4. Good luck, everyone.